In 2023, frontier LLMs struggled to maintain coherence between multi-step tasks. Now, the largest of models are able to navigate dense, long horizon tasks spanning several hours. Think end-to-end software development, search engine optimization work, long-form video understanding, and there's many more. These tasks are costly, time-consuming, and it's still difficult to get them working adequately even with these frontier models. One task, which is commonly used to benchmark a model's long horizon reasoning, is Pokemon Fire Red, a 2004 Game Boy Advance game that takes 30 hours to complete end-to-end. Pokemon Fire Red is a great candidate for this evaluation because sequencing required to beat the game necessitates a careful blend of long-term planning and short-term action. In fact, it's so difficult for LLMs to complete that it was only recently that Claude Fable 5 became the first LLM to successfully complete the game from beginning to end. So what if I told you that a model 600 times smaller than Claude Fable 5 could complete Pokemon Fire Red in half the time and for 1/1000th of the cost? Introducing PokeClanker 9 billion, a fine-tune of Quantum 3.59 billion that surpasses frontier performance on domain-restricted, long-horizon reasoning tasks. It utilizes supervised fine-tuning over 49 hours of gameplay, 6 text walkthroughs, and distillation from Gemma 3.5 Flash. PokeClanker excels at long-term planning. Under the hood, PokeClanker has been fine-tuned to utilize the Fire Red harness, a custom harness I developed to reduce the model environment friction and increase accuracy of short-term actions. Fire Red harness was built by decompiling Pokemon Fire Red to identify the underlying location of the game state in memory for the fastest and most accurate representations without relying on flaky user interfaces or image recognition. So how was it made? Well, the 49 hours of gameplay was sourced from 3 Pokemon Fire Red walkthroughs that I found on YouTube. This raw footage was parsed into state action pairs by a video understanding framework using Gemma 4 via Cerebrus. And informational frame detection was run over the videos by reverse engineering the H.265 video decoding, which essentially is a fancy way of saying that instead of feeding every single frame from the video, I was able to pick out the individual frames which are relevant for creating the state action pairs and extract them very efficiently. This allowed for all 49 hours to be pre-processed in less than 3 hours, which is about 16 times real speed. 6 walkthroughs were sourced and pre-processed into question-answer pairs based on general knowledge and strategy for the game. And then finally, Gemini 3.5 Flash was hooked up to the Fire Red harness and used to generate training samples matching the same state action pairs in the exact same format that Fire Red harness uses, which was used as a method of distillation. But that's a lot of data. So what were the results?